In this video, we're given that the cosine of pi over 12 is equal to 1/4 the sum of radical 6 and radical 2. And we're to find the sine of pi over 24 and cosine of pi over 24. Now the given result, the cosine of pi over 12, that's actually derived using the sum angles, or the cosine and the sine of the sum or difference of two angles. But in this problem, it's given. And we're going to use actually the half angle formulas here. The sine of theta over 2 is plus or minus the square root of 1 minus cosine theta over 2. You have a similar thing for the cosine of theta over 2. Now the plus or minus is determined by where the angle is, what quadrant. Obviously in quadrant 1, the sine or cosine of any angle is going to be positive, so we use the plus square root. An angle in quadrant, say 3 or 2, would have a negative cosine, so we take the negative sign. So there are the formulas, and notice theta over 2, this angle here, theta over 2, is half the given angle over here, theta. Or you can say that this angle theta is twice this angle over here. So here's the way I'm going to start it. I have the sine then of pi over 24, and pi over 24 is just in degrees, it's 15 degrees, so it's in the first quadrant, so obviously we have the positive square root. And then I'm going to say this is the square root, and we just plug in. So we have 1 minus, and the cosine of pi over 12, that's given to be right here. We just plug it in here. This will be 1/4 at the square root of 6 plus the square root of 2. And that's over 2. So we just multiply the numerator and the denominator by 2 here, or actually by 4, to get rid of this fraction here. So let me just put this way. Multiply everything here by 4, and everything down here by 4. Then I have the follow up right here. So 4 times 1 in the numerator will give me the 4 here, and then 4 times this coefficient here of negative 1/4 gives me a negative 1. And then notice this negative 1 then is going to multiply through this parentheses. So I just write it this way. This then will become a negative square root of 6 and a minus the square root of 2. And that's over 8 here. And let's erase this here. And this is really the answer right here, but it's not simplified. So I'm just going to rewrite it and say, I'm going to bring this out over here. So this will be 1 over the square root of 8. And that'll leave me on top with 4 minus the square root of 6. Minus the square root of 2. And then I'll go ahead and just multiply here by the square root of 2 outside. All I'm doing here is just simplifying or rationalizing this thing. So this will give me then the square root of 2 times 1. Give me the square root of 2. And the denominator, I'll get the square root of 2 times the square root of 8. That's the square root of 16, so that'll be 4. I'll just put this here. And everything else stays the same. This will then be the square root of 4 minus the square root of 6 minus the square root of 2. So that's the answer to the first part, sine of pi over 24. Now for the second part, the cosine pi over 24, pretty much the same problem here. Again, first quadrant, so it's going to be positive, so I take positive the square root. And the only difference is that this is a 1 plus cosine of pi over 12. So I put this up here. It's 1/4 here. Square root of 6. Square root of 2 over 4. And down here we have a 2. So the only difference was that this had a plus sign here, For the sine, this was minus, and over here it's plus. So if I do the same thing I did with the first part, this would just equal to square root of 2 over 4. You can see it's going to be identical, except these signs here would be positive. So this will be the square root of 4 plus radical 6 plus radical 2. And there you have it. Thanks for watching. We'll see you next time.